welcome back to my channel, and here we want to look at the method 2, or the alternative method or second method for obtaining the true shape of a triangular lamina. So what we need to do is to copy the given views as we are instructed in the question. So I have done that. So I've done that in the first video, which is the first method. I showed you how you can copy the given views, but I've done that for this method. I did that behind the scene. So this is still our XY line. Okay, so here we have what this is A, B, C, and then here we have A1, B1, and C1. Now let's go and see what we need to do to obtain the true shape of this triangular lamina, as we are told that these views are given in first angle projection. This is the plan and this is the front elevation. Now what we need to do now, we need to extend line AB so towards this side. So we extend line AB towards this side. So any length. So I will call this line, I will call it this point, I will call it point D. So I will call this point, I will call it point D. So I will call it D. Okay, so let me call it point D. Okay, so that is point D here. Okay, so we have D there. Alright, so this is point D. So we have this line to be line DB1. So that is what we have there. So the next thing that we are going to do is that we are going to construct a perpendicular line. So we are going to erect a perpendicular line around this on this line that will pass through this point C1. So a line that will be perpendicular to this line DB1, and then it will pass through this point C1. So that is what we are going to do now. So to do that, so I will set my protractor like this on this line DB1, and then you make sure the 90-degree line is on point C1. So that is what you need to do. Then the horizontal line that we have here, on this protractor, make sure is on the line DB1. So you need to make sure that it's on line DB1, and then the line that goes to 90 is at point C1. So I will put a dot here. And another thing that I need to take note here is that, so there's no point, I didn't put any point on this line, but this is what I'm going to do. So I'll just set my ruler like this on this vertical line that goes to 90. Then I will put a dot here. So I put a dot here so that the line can be a perpendicular line. So what I need to do now, so is to join the point together and to pass through point C1. So it goes like this. Okay, so it enters through the previous work that we did. So so don't mind that. Okay, so this line is at a right angle to line DB1. So then I need to call this point. So I will call this point, I will call it point E. So this is point E. So let's take note of that. Now the next thing that we are going to do is that we are going to draw a line through point C1, and that line will be parallel to this line DE, to parallel to line DE. So this is what I mean. So I want to draw a parallel line. At point C1. So and that line will be parallel to line DE. So what I need to do is to set my set square like this on line DE. Okay, then I will shift it to C1. Okay, then I will draw a line in this direction. Alright, so this line I will call it C1F. Alright, so we have drawn the line. So this line here, I'm supposed to call this line. So let me call it EFG. So this is EG, line EG. So this perpendicular line is line EG. So let's take note of that. Now the next that I'm going to do is that I'm going to draw a line, so a perpendicular line, so along this line DE that will also be parallel to this line. So what I need to do is this: at any distance, so I will set my set square like this and support it with the ruler. Then I will shift. So I will shift the set square to any distance that I like. So this is okay for me. So then I will draw this line. Okay, so this line is perpendicular to this line as it is parallel to line EG. So this point I will call it so GH. So this is point H here. So H, and this point I will call it point I. Okay, so this is line HI. So then the next thing that I'm going to do is that, so I will call this point, so this point here, this point I will have here, so I will call it point J. So this is point J, very, very important. Then the next that I'm going to do is that I will take my compass. So take my compass. So I will take my compass. So, and before I do that, I need to get the height of this triangle, the height of this triangle. So which is the distance from here to here. So I need to get the height. So I want it to be outside here. So I want it to be outside here. So I will draw this line. So this distance, so distance from here to here is the height of the, so I should have taken it from here to here, but I want it to be outside. So this is the height. So the height of the triangle. So this is the height of the triangle. So I'm going to take this distance. So I will take this distance. So from here to here. So the height of the triangle, I will take it like this. Okay. So I will take it, and then I'll put the midpoint at point J here. And then make an arc here. So this point, I will call it point K. So let's take note of that. So that's point K. So the next thing I'm going to do is that I will take my compass, put the pinpoint at H here. So putting the pinpoint at H here, and I will extend it to point K here. Okay. So extend to point K, then I will draw an arc like this. Okay. So this point, I will call it point L. Okay, so that's point L. Now, so from point L, I'm going to draw a line. I'm going to draw a line so that will be parallel to this line. So I need to draw a line that will be parallel to this line, C1F. So I will set my set square. So along this line, C1F. So, and then I will shift the set square to point L like this. Okay, so getting here, so here I will draw a line like this to meet this line. So this point here is point, so let me call it point C2. So this is point C2. So then if I join, I'm going to join, I will join A1, C2 together, and this line A1, C2 is the true length of AC. Is the true length of AC. Then I will also join B1, C2 together. So this line B1, C2 is the true length of BC. Is the true length of BC. So we have this now. So this is another method. So let's take the measurement. Let's take the measurement and see so what we are going to get. So here I have, so AB, so is equal to, and then BC, so is equal to, then we have what we have, AC is equal to. So let's take the measurement. So so for A1, B1, so we have this to be 72 millimeters. So when it comes to this work like this, there'll be variation. There'll be variation. So when you are taking the measurement, so it can be 70, 71, or 72. So if it's 71 or 72, don't worry. So you are still right, as long as it is still 70. So it is not less than 70. So we have this to be 72. So this is 72. So here I will have that AB is 72 plus or minus 1. Then let's take BC. So that is B1C2. As I said that it is the true length of BC. So if I take the distance from here to here, I'm looking at this. So this is something 60. This is 66 millimeters. It is still okay. So I will write 66 millimeters here. So 66 millimeters plus or minus 1. So you write like that. Then let's take A1C2, which is the true length of line of length side AC. So if I take it like this, so this is 47. So 47. So here we have 47. Okay, so plus or minus 1. So this is how you can use this alternative method to find the true shape of a triangular lamina. So all you need to do is to practice. Thank you and God bless you.